today we're learning a third method for solving systems of linear equations, and today's method is using something called elimination. So remember, we've already done graphing and substitution. Those both have, situations where they work really well, situations where maybe they're not the easiest method. Elimination is the same way. So our learning goal, I will write and solve systems of linear equations by elimination, and I will solve real-life problems. Okay, so we're going to want to use elimination when I have two equations and they are written in standard form where either one of the variables has the same coefficient or the coefficient of one variable is just a multiple of the coefficient of the other. So for example, this will make more sense when you see it written out. So in this case, when we look at these, if I look at the coefficients of my x's, the coefficients are both 1. So that tells me right away that this is going to be a good system to use solving by using elimination. You'll also see that like my y coefficients are 3 and -3. That just happens to be a coincidence for this problem. But that by itself, just that 3 and -3, that would be another good sign that elimination would be a good method to use for this. So what we're doing is we're trying to get rid of one of our variables. That's why it's elimination. We're eliminating a variable. So in this case, if I look at these two equations, and let's try and eliminate the y. If I add these two equations together, if I do the top equation plus the bottom equation, I'll get 2x. Let's write it out. And then I have a positive 3y, and I'm adding a negative 3y. That just makes 0. So I won't have any y's. And then on the right-hand side, I have -2 plus 16, and I get 14. So what I did here is I eliminated the y's. They had opposite coefficients. That meant when I added the two equations together, these came together to make 0. Now I just have 2x equals 14. I can solve really easily for x by dividing by 2, and I get x equals 7. And now I can go back to using the method that I used with substitution, where I substitute that 7 into either equation. I'm going to substitute it into the first one just to make life easy. So 7 plus 3y equals -2. I just substituted 7 in for x. Subtract 7 from each side. I get 3y equals -9. Divide each side by 3, and I'll get y equals -3. So my solution is 7, -3. That's just one example of where elimination is a good way to solve. Let me give you another example. If I had 2x minus y equals 9, and 4x plus y equals 21. I'm going to want to use elimination here because again you'll see that my y's have opposite coefficients. This coefficient's -1, this coefficient is +1. So when I add these two equations together, 2x plus 4x is 6x, -y plus +y is 0, and 9 plus 21 is 30. I divide each side by 6, and I get that x equals 5. Then I just need to substitute that into either equation. 2 times 5 minus y equals 9. So 10 minus y equals 9. We can see pretty obviously that y is going to have to be 1, but if I actually solve, I get -y equals -1, so y equals +1. My solution then is 5, 1. We can check this just like we did before. Let's plug it into the second equation. 4 times 5 plus 1 equals 21, maybe. 20 plus 1 hopefully equals 21. Sure enough, it does. So there was another example. Let's have you try one on your own. How about negative 5x plus 2y equals 13 and 5x plus y equals negative 1. Go ahead and try that one on your own, and then we can check it together. So what I'm going to want to do is I look at my coefficients and I see that my x's have opposite coefficients. If I add them together, my x's will be eliminated because negative 5x plus 5x equals 0. So when I add these together, I get 0. Here I have 2y plus y, and I get 3y. And I have 13 plus a negative 1 over on this side, which is 12. So to solve for y, I just have to divide each side by 3. I get y equals 4. Of course, I need to substitute this back in so I know what so I can tell what my x value is. It doesn't matter if I plug it into the first equation or the second equation. So let's put it in the second. 5x plus 4 equals negative 1. So I'm going to subtract 4 from each side, and I'll get 5x equals negative 5. Divide each side by 5, and I get x equals negative 1. So the point negative 1, 4 is my solution to this system. Let's plug that into the first equation to make sure it works. Negative 5 times negative 1 plus 2 times 4 equals 13. That's negative 5, plus 8. Oh, I'm sorry. That should be a positive 5. So 5 plus 8. There we go. I thought I was wrong for a second. 5 and 8 make 13. So it works for the first equation. The second equation it works for as well. So I know that this is going to be my solution. Here is another situation when I'm going to want to use elimination, although it's not quite as evident up front, because you'll notice my coefficients for x are 3 and 6, the coefficients for y are 1 and 3, so I don't have any of the same coefficients. What I need to do is I need to multiply either one or both of the equations by a constant in order to get the same coefficients. So I need to decide if I'm going to eliminate x or if I'm going to eliminate y. It doesn't matter, I could do either. In this case, I can see that if I multiply 3 by 2, I'll get 6. So what I'll do is I'm going to multiply that entire top equation by 2. And when I say the entire equation, I mean every single term on either side of the equal sign. So this top equation will be 2 times 3x, which is 6x, plus 2 times y equals 2 times 11, which is 22. I multiplied the entire first equation by 2. Now I'm going to keep the second equation exactly the same. And now I see that I have the same coefficient. Now in this case, these are not opposites, they're the same. So what I'm going to have to do is subtract the second equation from the first. When I do this, I want to be super careful with my signs. Everything here is positive, so it shouldn't be too bad. But you may have other situations where you have negative numbers. Remember, subtracting a negative is actually adding. You want to be really careful about that. So when I subtract these, 6x minus 6x is 0, plus 2y minus 3y is a negative y, and 22 minus 24 is negative 2. If the opposite of y is negative 2, then y is going to be a positive 2. Now I take this and I substitute it either for that y or that y. It doesn't matter which one. Let's put it in the first. So 3x plus 2 equals 11. Subtract 2 from each side and I'll get 3x equals 9. Divide this by 3, divide this by 3. And I get that x equals positive 3. So my solution should be 3, 2. Let's put it in here real quick. 6 times 3 is 18. plus 3 times 2 is 6, is 18 plus 6, 24. Yep, that's 24 equals 24. So that's a pretty good indication that I did this correctly. I'm going to give you one to work on your own. And just remember that you're trying to get one of the variables to have the same coefficient. So either both of your x's have the same coefficient or both of your y's have the same coefficient. So let's use this problem. 4x minus 5y equals negative 19. Negative x minus 2y equals 8. So it's going to be up to you to decide which variable you want to eliminate first. So go ahead and work on that. Okay, for me, I see pretty obviously, if I have a 4 here, and if I make this x a negative 4, those will eliminate. So I want to multiply my bottom equation by 4. That's not my only option here. Another way of solving this, it's kind of like when you find a common denominator, where I could multiply this top equation by 2 and the bottom equation by 5, and that would make the coefficients for my y 10 in both cases. So that's also a possibility. You don't have to multiply just one equation. You can multiply both of them to make the coefficients the same. But in this case, I'm just going to multiply by 4. I think it's a little bit easier to do. So 4 times negative x is negative 4x minus 4 times 2y is 8y. And don't forget to multiply this 8 by 4 as well. 4 times 8 is 32. My top equation stays exactly the same. 4x minus 5y equals negative 19. When I look at my coefficients, I see that I have a positive 4x and a negative 4x. So if I add those together, I get 0. So I'm eliminating x's here. I have negative 5y plus a negative 8y. That's negative 13y. And a negative 19 and a positive 32 is going to give me a 23. That's not right. Oh, I'm sorry, 13. I forgot how to add for a second. That's going to give me a positive 13. So divide each side by negative 13, and I'll get y equals negative 1. Now that I know what y equals, I can substitute that into either equation. Let's substitute it into the bottom one. Negative x minus 2 times negative 1 equals 8. Negative x, I'm subtracting a negative 2, which is the same as adding 2. Subtract 2 from each side, I get negative x equals 6. So x is going to be negative 6. So my solution is negative 6, negative 1. And then if I substitute in here, 4 times negative 6 is negative 24. 5 times negative 1 is a negative 5. So negative 24 plus 5 will give me negative 19. So that tells me that's my correct answer. Now, you are going to have a real-world situation that comes with this, and really with these real-world problems, the biggest thing is coming up with your equations to begin with. So if we have 340 calories in 2 cups of cereal with 1 cup of milk, and you don't need to write this down. And we also know that there are 570 calories. That's a lot of calories. 570 calories in 3 cups of cereal with 2 cups of milk. I want to know how many calories are in 1 cup of cereal, how many calories are in 1 cup of milk. So I need to set up my equations first. Let's call cereal X, let's call milk Y. So 2 cups of cereal is 2x. 1 cup of milk would be y. So 2 cups of cereal plus 1 cup of milk gives me 340 calories. 3 cups of cereal is 3x. 2 cups of milk is 2y. That equals 570 calories. So this is the setup for my equation. And what I need to do is eliminate a variable. I can either eliminate x's by using a coefficient of 6, so I'd multiply the top equation by 3, the bottom equation by 2, or even easier, if I have 2y and just y, if I multiply the top equation by 2, I'll be able to eliminate that y pretty easily. So multiply the top equation by 2, and when I do that, I have 2 times 2x, which is 4x, plus 2 times y is 2y, and that's going to equal 2 times 340, which is 680. Now I have a 2y, I have a 2y here, so I can just keep my second equation the same. And now, because I have positive coefficients, I need to subtract my equations to eliminate that y. 4x minus 3x is x. 2y minus 2y is 0, and 680 minus 570 is 110. So that tells me that x, which was 1 cup of cereal, is 110 calories. If I want to know how many calories are in a cup of milk, though, I need to take that and substitute it into either one of my equations. Let's put it in the first one. 2 times 110 plus y equals 340. So those 2 cups of cereal are 220 calories. If I subtract 220 from each side, I get that 1 cup of milk is 120 calories. So 1 cup cereal is 110 calories. 1 cup milk, M-I-L-K, is 120 calories. And I can check that with the second one. 3 times 110 is 330. 2 times 120 is 240. 330 and 240 is 570. So that checks out okay. So that's the idea behind elimination. If you look in your book on page 172, it gives you a little chart that tells you when you want to use the different methods. I can show that to you, but you can also look page 172. So graphing, if we just need to estimate a solution, graphing is a good idea. If we're given 2 equations that are in slope-intercept form and they look like they'd be easy to graph, that would be another situation when you want to graph. For substitution, if one of the variables has a coefficient of 1 or -1, and it's really easy to get that variable by itself, that would be a good situation for using substitution to solve. For elimination, if you have a pair of like terms, so if your x's or your y's have the same coefficient or opposite coefficient, you can just do straight elimination without having to multiply it all. That was like the first problem we did. If we can't just eliminate by adding or subtracting, so like this one right here, we needed to multiply by 2 first to get the same coefficient for our y's. That's when you're going to use elimination using multiplication first. You really can use any method with any problem, but you'll find that just some problems are set up better for certain methods. So these are your methods for solving your systems, and you now know all you need to know to solve systems of linear equations.